Now on to the mean value theorem. So what the mean value theorem says is this. If f is continuous on the open interval AB, oops, already messed it up. If f is continuous on the closed interval AB and differentiable on the open interval AB, then f prime of c has to equal f of b minus f of a over b minus a for at least one c in the open interval a to b. So what does this mean? Well, geometrically, if we were to graph it out, what this theorem says is this. You have a function that is continuous on the closed interval a to b, so a and b are included in the graph, they're filled in endpoints. It's differentiable, so there's some smooth curve that goes from a to b. I'll just kind of draw a nice, easy, smooth curve like that. What the theorem says is that the exact slope which is f prime of c, has to equal the average slope from a to b, right? Because this gives you the slope between those 2 points. It gives the slope of this line right here. Right, the slope of that line is the change in y over the change in x. And according to the mean value theorem, for a continuous and differentiable function, there's got to be some point c, looks like right about here probably, where the tangent line, over here actually, the tangent line to the graph at that point has the exact same slope. Which actually makes sense. If you think of the derivative as being the rate of change of the graph, it's like how fast the graph goes. So for example, velocity is the derivative of position. And what this theorem says is pretty much you can't average a speed unless you go that exact speed somewhere on your trip. So if I am driving to the grocery store and I average 30 miles per hour for the drive, I have to go exactly 30 miles an hour at least once during my drive. I can't average that speed unless I go that speed at least once. And the same is true for functions. A function can't average this rate of change unless it has that rate of change at least once on its path. So that's all the mean value theorem says. It doesn't tell you how to find this point, c. It just tells you that c exists. This is called an existence theorem. All this theorem tells you is that this point c exists, not how to find it. Let's prove this theorem. Since it is so tremendously important for the rest of calculus, we'll take the time to do the proof. So the proof, which by the way, if you go to Stellar and look up the lecture notes for lecture 5, I did the proof all out with pictures and diagrams to make it as understandable as possible. But for the proof, we're going to start off by assuming that the conditions of the mean value theorem are met. So, I'm supposed to say let, not left. So let f be continuous on AB and differentiable on AB. And let some line, I'll call it y sub AB, be the line that goes through the points a f of a and b f of b. So if I was to draw a sketch of what I just said, here we have a, here we have b. I'll use a similar graph that we had for our example on the previous page. That's f of x. And then the line y sub AB is the straight line that goes through the endpoints. So since AB goes through these two endpoints, A, f of A, and B, f of B, that means that the equation for line y sub AB, if I use point slope form, it's just the y value. I'll use this point as my starting point. It's the y value plus the slope, which is the change in y over the change in x, times x minus the x value. That's the equation for y sub AB. Lastly, consider a new function, phi of x. Phi of x gives you the vertical distance between f of x and y sub AB. So the distance between those 2 points is phi of x. And phi of x, if I write down this equation, is f of x minus this line. So minus f of A minus f of B minus f of A over B minus A, x minus A. And why we did this is that phi of x satisfies Rolle's theorem. Because at the endpoints A and B, phi of x is 0, since f of x and y sub AB intersect there. The difference is 0. And since f of x and y sub AB are continuous and differentiable, their difference, phi of x, will also be continuous and differentiable. This means that phi prime has got to be 0 somewhere for some point C. And so all we have to do is just do the algebra for this. Use this equation right here, find phi prime of C equals 0, and do it out. So what's phi prime? Well, phi prime of x equals f prime of x minus f of A is constant, so that term goes to 0. This is a linear term, so its derivative is just the coefficient in front of x. So this is the derivative of phi. Phi prime of C has got to be 0. So when we plug C into this, f prime of C minus the average slope from A to B equals 0. And I'm short on space, but if you add over this term to the right side, you get the desired result. F prime of C has got to equal the average slope. So that is the mean value theorem. And again, I think the best way to think of it is in terms of speed. You can't average a speed unless you go that exact speed somewhere in your trip.